Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss circles. In this chapter, we are going to discuss the problems in the exercise 10.4, page number 179 in the textbook. In this exercise, we have completed 4 questions so far. I hope you have understood well. I hope you have learnt well. Haven't you, my dear children? Right. Now come to the question number 5. Three girls, Reshma, Salma and Manideep, are playing a game by standing on a circle of radius 5 meters drawn in a park. Okay, my dear children, this is a rough diagram for the given data. Let us consider this is a circle with a center O. Radius of the circle is 5 meters. In this park, this is a circular ground, circular field. On this circular field, here let us assume that Reshma, Salma and Manideep are standing. Reshma throws a ball to Salma. Salma to Manideep. Manideep to Reshma. Like this, they are throwing balls. Okay, my children. Reshma throwing a ball to Salma, and Salma is throwing a ball to Manideep, and Manideep is throwing the ball to Reshma. Okay, my children, understood this point? If the distance between Reshma and Salma and between Salma and Manideep is 6 meters each, the distance between Reshma and Salma and Manideep distances are 6 meters each. Okay, my children, understood this point? Then what is the distance between Reshma and Manideep? So in this case, we have to find the distance between Reshma and Manideep. So for the given data, I have drawn a rough diagram. See the adjacent figure. Okay, my children. Now come to the solution part. In the adjacent figure, let R, S, M denote the positions of Reshma, Salma and Manideep respectively on a circle of radius 5 meters and with the center O. Okay, my children, understood this sentence, understood this step? Right. We have drawn a rough diagram for this given data. And what is measurements here? OR is radius. Yes or no, my children? Therefore, OR is equal to 5 meters. RS is equal to 6 meters. SM is equal to 6 meters. Okay, my children, this is the given data. We have to find the length of the line segment RM, the distance between Reshma and Manideep. Understood this point, my children? To find this distance, let us make a construction. Let us join OM. Okay, my children, OS. And we have to draw a perpendicular line OL to RL. RS. Okay, my children, construction. We are making a construction. What is that to making construction? Join OM, OS. Okay, my children, and draw OL perpendicular to RS. Draw OL. Okay, my children, OL perpendicular to RS. Understood this step, my children? This is the construction. To find the length of the line segment RM, we are making this a construction. Okay, my children, understood this point? Right. Let OS intersect RM. OS intersects RM at K. Okay, my children, let us assume that this OS is intersecting this line segment RM at K. Okay, my children. Now, if you observe this quadrilateral ORSM, This is a kite because this side and this side, these pair of adjacent sides are equal. Here 6 centimeters, here 6 centimeters. These are also equal. Okay, my children. Quadrilateral OR SM is a kite because because a pair of two pairs of adjacent sides are equal in a quadrilateral. So in a quadrilateral, if two pairs of adjacent sides are equal, then the quadrilateral is said to be a kite. Understood this point, my children? Why we have written this is a kite, right? Then immediately you have to, then OS and RM are diagonals of the kite. Yes or no, my children? Then OS and RM are diagonals of the kite. Diagonals of the kite ORSM. Okay, my children. Therefore, RM is perpendicular to OS, or OS is perpendicular to RM, because in a kite, but diagonals are perpendicular. Okay, my children. Diagonals are perpendicular in a kite. So by this property we have written that OS is perpendicular to RM. Okay, my children. So therefore this is automatically perpendicular. Yes or no, my children? OK is also perpendicular to RM. This implies OK is perpendicular to RM. Yes or no, my children? OK is perpendicular to RM. And RK is perpendicular to OS. RK is perpendicular to, and RK is perpendicular to OS. Yes or no, my children? Right. Now let us take the line OL. It is we have drawn OL is perpendicular to RS. Yes or no, my children? We have drawn OL perpendicular to RS. This implies OL bisects RS. Yes or no, my children? OL bisects RL because the line drawn perpendicular from the origin to a chord bisects the chord. Okay, my children. There is a property. The perpendicular from the center. Since the perpendicular from the center of a circle, to a chord bisects the chord. So by using this property, we say that here OL bisects RS. Bisects RS. This OL, this line is a perpendicular line drawn from center of the circle to this chord RS. So OL bisects RS. Understood, my children? Therefore, RL is equal to LS is equal to 3 meters. Yes or no, my children? Right. Now, if you observe, this is a right angle triangle. Yes or no, my children? This is a right angle triangle. O or L is a right angle triangle. In triangle, right angle triangle O or L, let us use the Pythagoras theorem. OL square plus RL square is equal to OR square by Pythagoras theorem. Okay, my children, understood this step? By the Pythagoras theorem, we wrote this step. OL square plus LR square RL square is equal to OR square. Okay, my children. This implies OL square. We don't know the measurement of OL. RL is 3 meters. 3 square is equal to OR, because RL is equal to 3 meters and OR is equal to 5 meters. Understood this point, my children? OL square plus 9 is equal to 25. This implies OL square is equal to 25 minus 9. That is equal to 16. Okay, my children, understood this point? This implies what will get OL is equal to square root of 16. This implies OL is equal to 4 meters. We got here OL, length of the line segment OL. Okay, my children, understood this point? Means height of this triangle ORS. Okay, my children, understood this point? Right. Now let us find the area of triangle ORS. Okay, my children? Right. Area of triangle ORS is equal to area of triangle Okay, my children, area of triangle ORS is equal to area of triangle OSR. Both same, both they represent the same. Okay, my children. What is the formula? Half into base into height. Okay, my children. Here also are half into base into height. Okay, my children. This implies half into, in this triangle ORS, here I am taking RS as base, RS into height OL. Okay, my children, RS into OL is equal to half into, here I am taking OS as base and RK as height. Okay, my children, OS into RK. Understood this step, my children? Right. This implies here we can strike out off on both sides. We get cancel on both sides. What is RS value here? RS is 6 meters. Yes or no, my children? 6 into what is OL? 4. Okay, my children, is equal to what is OS here? 5 into RK. Okay, my children, got it? So, what you get here? This implies RK is equal to 24 by 5. As our number children, 2, 6, 6 4s are 24. So, we are transposing 5 this side, it becomes by 5. Okay, okay, my children? Right. But here, RK is a midpoint because it is also a perpendicular drawn from or the center of the circle. Yes or no, my children? So Rm is equal to 2Rk. Okay, my children. Therefore, Rm is equal to 2Rk. Okay, my children. That is equal to 2 into what is the Rk here? 24 by 5. That is equal to 48 by 5 meters. Otherwise, you can convert this fraction into decimal form. Divide 48 by 5. 5 nines 45. 5 6 term. So 9.6 meters. Okay, my children. This is the distance between Rashma and Manideep. Understood, my children? Right. Hence, the distance between Rashma and Manideep is equal to 9.6 meters. Okay, my children, understood this point? Right. Now come to the next question, that is question number 6. The last question in this exercise. Okay, my children, a circular park of radius 20 meters is situated in a colony. Okay, my children, let us assume that this is a circular park of radius 20 meters. This is the radius of the circular park. Three boys, Ankur, Syed and David, are sitting at equal distance on its boundary, each having a toy telephone in his hands to talk each other. Okay, my children, let us consider this is a toy telephone. Okay, my children, string of the toy telephone. This is the string of the toy telephone. This is the string of the toy telephone. Okay, my children, find the length of string of each phone. Okay, my children, all are equal distances. AB is equal to BC is equal to CA. Okay, my children, here given. So come to the solution part. I have drawn a rough diagram for the given data. In the adjacent figure, let A, B and C denote the positions of three boys, Ankur, Syed and David, sitting at equal distance on a circular park boundary of radius 20 meters. Let O be the center of the circle. Okay, my children, understood this point? Right. Therefore, AB is equal to BC is equal to CA. We have to find the length of the line segment AB. Each are equal to BC and CA. Okay, my children. Right. Now, let us construction. Let us construct. Let us construct OD perpendicular to BC. Okay, my children. Before to that, let us assume that this length BD is X. Okay, let us construction. Draw OD perpendicular to BC. Okay, my children. Right. Now, BD OD is perpendicular to BC. Then immediately BD is equal to DC. Yes or no, my children? Therefore, BD is equal to DC because this is a perpendicular drawn from center of the circle to this chord BC. Because the perpendicular drawn from center of a circle to a chord bisects the chord. Since the perpendicular drawn from center of the circle to a chord bisects the chord. So here OD is drawn perpendicular to this chord. Therefore, this OD bisects this line segment, this chord BC. Therefore, BD is equal to DC. Understood this step, my children? Right. Let us assume that BD is equal to X. For our convenient, let BD is equal to X meters. BD length is X meters. Understood this step, my children? Right. So, here we assumed that BD is equal to X. BD is equal to X meters. Okay, my children. So here we have drawn OD perpendicular to BC. Yes or no, my children? So in triangle, in right triangle OBD, in right triangle OBD, in right triangle OBD, let us apply the Pythagoras theorem. Okay, my children. BD square plus OD square, BD square plus OD square is equal to BD square plus OD square is equal to BO square by Pythagoras theorem. By Pythagoras theorem, we got this step. We wrote this step. Understood this step, my children? Right. In this equation, in this step, what is BD here? X. So X square plus what is OD here? We don't know. OD square is equal to BO square. What is BO? 20. Okay, my children, we substituted the values. This implies X square plus OD square is equal to 400. 20 square value is 400. Understood this step, my children? Right. This implies OD square is equal to 400 minus X square. Okay, my children, understood this step? Right. This implies OD is equal to square root of 400 minus X square. Okay, my children, understood this one? OD is equal to square root of 400 minus X square. Okay, my children? Right. Now let us find area of equilateral triangle ABC. Area of this equilateral triangle ABC. Okay, my children. This is also X. Yes or no, my children? So BC is equal to 2X. So AB is also 2X and AC also 2X. Yes or no, my children? Okay. Now area of equilateral triangle ABC. What is the formula? Root 3 by 4 side square. Root 3 by 4 A square. Okay, my children. That is equal to root 3 by 4. Here, what is the side BC? Okay, my children. BC square. BC square. Okay, my children. Understood this step. So, root 3 by 4. BC means x plus x. Yes or no, my children? 2x whole square. Okay, my children, understood this step. So root 3 by 4 into 4x square. 2x whole square value is 4x square. Okay, my children, understood this step. Right, here 4 gets cancelled. That is equal to root 3x square. This is area of this equilateral triangle ABC. Okay, my children. But area of triangle ABC can be found by adding area of triangle OAB plus area of triangle OBC plus area of triangle OCA. Yes or no, my children? Now, area of triangle ABC is equal to area of triangle OAB plus area of triangle OBC plus area of triangle area of triangle OCA. Okay, my children. Here, if you observe this triangle, and this triangle, all these three triangles are equal. Okay, my children. By side property, all are congruent triangles. Okay, my children. Therefore, we can write area of triangle OBC, area of triangle OBC plus area of triangle OBC plus area of triangle OBC, because triangle OAB is congruent to triangle OBC, congruent to triangle OCA by SSS. All these three triangles are congruent to each other. Congruent triangles. Understood this step, my children? Right. That is equal to 3 into area of triangle OBC. Okay, my children, understood this step? 3 into area of triangle OBC. Right. Now let us find the area of triangle OBC. That is equal to 3 into half into base into height. Okay, my children, that is equal to 3 into half into base is base BC into height OD. Okay, my children, for this triangle OBC, I have taken BC is a base and height is OD. Okay, my children, right? That is equal to 3 by 2 into BC into OD. Okay, my children, by multiplying this, we get like this. Understood this step, my children? 3 by 2 into what is base here? 2x. X plus x. Okay, my children, 2x. Length of the line segment BC is 2x into OD. What you got here, OD? 400 minus x square. Yes or no, my children? Right. Here 2 gets cancelled. Then what you get? 3x into root of 400 minus x square. Okay, my children. 3x into 400 minus x square. But previously we have found area of triangle ABC, that is root 3x square we got. Okay, my children. Therefore, 3x into square root of 400 minus x square is equal to root 3x square. Okay, my children, understood this step? Here we can get x gets cancelled. 3 into root of 400 minus x square is equal to root 3. Understood this step, my children? We have cancelled x on both sides. Okay, my children, understood this step? Then we got 3 into square root of 400 minus x square is equal to 3x. Okay, my children. Now squaring on both sides. Do you remember this full form, my children? Squaring on both sides. Okay, my children. Right. So 3 root of 400 minus x square whole square is equal to root 3x whole square. Understood this step, my children? Right. Then what will you get here? 3 square 9 into, here we remove the square root symbol, 400 minus x square is equal to what will get? 3x square. Understood this step, my children? Right. Here 3 1 times, 3 3 times. Okay, my children. So 3 into 400 minus x square is equal to x square. Understood this step, my children? Right. Multiply. Use the distributive property. 1200, 3 into 400, 1200 minus 3x square is equal to x square. Understood this step, my children? Right. Now transpose minus 3x square to that side. Then x square plus 3x square is equal to 1200. Understood this step, my children? Right. This implies what you get? X square plus 3x square, 4x square is equal to 1200. Okay, my children. Right. This implies x square is equal to 1200 by 4. See, transpose 4 to RHS, it becomes 1200 by 4. Okay, my children, understood this step? 4 300 times. So, x square is equal to 300. Okay, my children, understood this step? This implies x is equal to square root of 300. What is the square root of 300? 10 root 3. Yes or no, my children? This is the value of x. But BC, therefore BC is equal to 2x. That is equal to 2 into 10 root 3. That is equal to 20 root 3 meters. Okay, my children. Therefore, AB is equal to BC is equal to CA is equal to 20 root 3 meters. Understood this step, my children? Right. Hence, finally, we write hence the length of string of each phone is 20 root 3 meters. Okay, my children, understood? Right. The problems in the exercise 10.4 was completed. Now let us start the concepts of exercise 10.5. Okay, my children? Right. In this exercise 10.5, we discuss angles subtended by an arc of a circle. In the previous exercises, we have discussed the angle subtended by a line segment at the center of a circle. Yes or no, my children? Or the angle subtended by a line segment at a point. Okay, my children, we have discussed that point in the previous exercises. Do you remember that point, my children? Right. Now come to this point. If two chords of a circle are equal, then their corresponding arcs are congruent. And conversely, if two arcs are congruent, then their corresponding chords are equal. Okay, my children, understood this point? To understand this point well, let us take an example. In the adjacent figure, let O be the center of the circle, and AB and CD are two chords of equal length. Let us see this figure, my children. Observe this figure. In this figure, let O be the center of the circle. AB is a chord and CD also another chord of this circle. And these two chords are of equal length. Okay, my children. Then we say that arc AB, this arc AB is congruent to arc CD. Okay, my children. Understood this point? Conversely, if arc AB is congruent to arc CD, then the corresponding chord, that is AB, is equal to chord CD. Length of the chord AB is equal to length of the chord CD. Is this point clear, my children? Right. Now come to the second point. Congruent arcs or equal arcs of a circle subtend equal angles at the center. Here also, to understand this point well, let us take an example. In the adjacent figure, O be the center of the circle. Let O be the center of this circle. Okay, my children. We have taken arc AB is congruent to arc CD. Okay, my children, arc AB and arc CD are congruent arcs. Then the angle subtended by this arc at center, that is angle AOB, is equal to the angle subtended by this arc at the center is angle COD. These two angles are equal. Okay, my children, remember these points, my children. These are very helpful, very useful, very important in solving the sums in the exercise 10.5. Okay, my children. Right. Now come to the theorem 10.8. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, my dear children, to understand this point well, let us take an example. Let us consider O be the center of the circle. In the adjacent figure, let us assume that O be the center of the circle. Let arc AB, this arc AB subtends an angle at C is X. Okay, my dear children, X degrees here. Then angle AOB, this arc subtends an angle of 2x at the center of the circle. So angle AOB denotes the angle subtended by an arc at the center of the circle is equal to angle ACB. The angle subtended by that arc AB in the remaining part of the circle at any point on the remaining part of the circle. Understood this point, my dear children? Is this point clear? Right. Now come to the theorem 10.9. Angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. Previously we have discussed segments. Major segment, minor segment. Okay, my dear children. Minor arc, major arc. In the adjacent figure, see this. Observe this figure, my children. Angle APC, angle ACB. These two angles are equal because suppose if you take this segment AB, join AB. If you join AB, if you join these 2 points AB, then this is a major segment. Yes or no, my children? The circle is divided by this chord AB into 2 segments. This is a downside is a minor segment, above the side is a major segment. In this major segment, if you take any point, then this arc makes an angle at these 2 points. These two angles are equal. That is angle APB. Angle APB is equal to angle ACB. Understood this point, my dear children? Right. Now come to the theorem 10.10. Theorem number 10.10. If a line segment join 2 points subtends equal angles at other 2 points lying on the same side of the line containing the line segment, the 4 points lie on a circle. They are called concyclic. The 4 points are said to be concyclic. In this case, these 4 points are said to be concyclic. Okay, my dear children. To understand this point well, let us take a rough diagram. Suppose A and B are 2 points. This is a line segment joining the 2 points. These 2 points, the line segment joining the 2 points subtend equal angles. So this line segment is subtending at point C, and the line segment, same line segment subtending the angle at D. If both are equal, these two angles are equal. Understood this point, my children? Previously we have discussed the angle subtended by a line segment at a point. So here these are 2 points in the same plane, the same side of this line segment. Okay, my children? Then this line segment subtending some angle x at point C, the same line segment subtending an angle x at point D. Okay, my children, it means these two angles are equal. Understood this point, my children? Then these 4 points are lying on the same circle. Means the 4 points are said to be concyclic. What are these 2 points called, my children? Concyclic. Understood this point, my children? The 4 points lie on a circle. Understood this point, my children? So we can draw a circle. We can draw a circle passing through these 4 points like this. Understood this point, my children? Is it clear? Right. Now come to this definition, my children. Cyclic quadrilateral. What is meant by a cyclic quadrilateral? A quadrilateral ABCD is called cyclic if all the 4 vertices of it lie on a circle. Understood this point, my children? Understood this definition? See, in this adjacent figure, to understand this definition well, let us take a diagram. Cyclic quadrilateral. ABCD is a cyclic quadrilateral. In this figure, the quadrilateral ABCD is said to be a cyclic quadrilateral. How do you say? Because all the four vertices A, B, C, D, all the four vertices of this quadrilateral lie on a circle. Yes or no, my children? That is why this quadrilateral is said to be a cyclic quadrilateral. Understood this definition, my children? Right. Now come to the theorem 10.11. Theorem number 10.11. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. This is the property of cyclic quadrilateral. What is the property? The sum of opposite sides, the sum of opposite angles, angle A plus angle C is equal to 180 degrees, and angle B plus angle D is equal to 180 degrees. Understood this point, my children? In a cyclic quadrilateral, either pair of opposite angles of a cyclic quadrilateral is 180 degrees. That is why in this figure, angle A plus angle C is equal to 180 degrees, and angle B plus angle D is equal to 180 degrees. Okay, my children, understood this point? Right. Now come to the theorem 10.12. 10.12. If the sum of a pair of opposite angles of a quadrilateral is 180 degrees, the quadrilateral is a cyclic. Just converse of this theorem number 10.11. This is just converse of this theorem. Okay, my children. In a quadrilateral, the pair of the sum of a pair of opposite angles, sum of opposite angles is 180 degrees, then the quadrilateral is said to be a cyclic quadrilateral. Understood this point, my children? Right. These are the points which are useful, which are used in solving the sums in the exercise 10.5. Okay, my children, all of you go through the textbook once. Okay, my children, then you can understand these points well. Okay, my children, right.